Hey everyone, welcome to Hawks Tutoring. Hope you're having a great day. Today we'll be doing question 19 of chapter 8D. So this is your volumes of solid of revolution chapter. And this is, I guess, a slightly tricky question. So that's why I want to make a video on it. So let's have a go at the question and we'll see how it goes. Question 19. The shaded region is rotated around the x-axis to form a solid of revolution. Find the volume of this solid. Okay, so this area right here, which is your shaded region, it's going to be rotated around the x-axis, so this axis. And if you rotate this area around, you get some, it's not a ball, it's not really an oval, but it will look something like this, like an acorn or something. Not slightly like an acorn, but you get what I mean. So that's pretty much the volume that you want to find, right? Okay, so typically when you're finding the volume, and it's between two curves, which is what this is, then you go the top square. So the formula for volumes is pi between two curves is, okay, your upper and lower terminal, and then you get your top square. So whichever curve's on the top, you square that, and then you minus the curve that's at the bottom, and then you square that as well. But in this case, very similar to the area topic video, tutorial video that we did last time, there is no clear top, there is no clear bottom, right? So if you have a look at this, it doesn't really look like there's any top or bottom. So once again, you cannot apply this volume formula. What you can do instead, similar to the area once again, is that you can split your area, or your volume in this case, into two. You can split it from 0 to whatever this intersection point is, and then from that intersection point to 2. If you can split them apart and then find the volume of, let's say, the red area, so this one right here. You can find the volume of this area rotated around the x-axis, added with the volume of this blue area rotated around the x-axis as well. If you add those two volumes together, you'll get the same volume. It's very similar to your area question, okay? The one that's between two curves where there's no clear top or bottom. Right, so how would you find the volume of these two areas? Well, the first thing we need to do is find the intersection point, right? So let's find the intersection point first. How do you find this intersection point? Well, we know y squared is equal to 3x, and the other one is a circle, x squared plus y squared equals 4. You can sub in the y squared equals 3x inside your other curve, your circle equation. So that is x squared. We sub in 3x over here into the y squared. Don't square that again, and then that's equals to 4. Of course, x squared plus 3x minus 4 equals to 0. Therefore, our intersection is x minus 4, or x plus 4, and then x minus 1 equals 0. And you get x equals to -4 or x equals to 1. Well, let's pick which one, let's see which one should be the right one. We know that x is on the positive, the first quadrant, or the intersection point on the first quadrant, and that means x has to be equals to 1 because it's clearly on the right. So x bigger than 0, therefore x equals to 1. So your intersection point is actually midway. It doesn't seem like it, but never trust the graph, okay? Find your own intersection point, then use your calculation to solve for the answer. Let's rotate some volume. So if you want to find the volume of the red curve, volume of the red curve, that is equals to pi. Always have a pi, and then it's your integrand. Upper terminal, that's 1. Lower terminal, that is 0. So it's from 1 to 0. And then it's the your function squared. So you already have a y squared in there. You don't have to square it again. Okay, remember the formula is v equals to pi, upper terminal, lower terminal, y squared, and then antiderivative in terms of x, right? So you need the y squared equivalent of x. And in this case, you already have y squared. So that's it, just 3x. Do not square the 3x again. You will get it wrong. So that's volume of the red curve. If you want to find the volume of the blue curve, well, that's the same thing. So it's pi, upper terminal, that's from 2, lower terminal, that's 1, 2 to 1, and then it's your circle equation. So what is a circle? X squared plus y squared equals 4, right? We want to find y squared in terms of x, so that is y squared equals 4 minus x squared. So what you sub in here is 4 minus x squared, because it's already in terms of y squared, okay? Then all you have to do is just antidiff these two, and you'll get your volume. So let's do that quickly. And antidiff of 3x gives you 3 over 2x squared, sub in the 1, sub in the 0, and then antidiff of this part right here, 4 becomes 4x, x squared becomes 1 on 3x cubed, we sub in 2, we sub in 1. Okay, so let's sub in the 1, that gives us 3 on 2, you sub in 0, you get 0, so ignore that. You sub in the blue part, so let's sub in 2, we sub in 2 here, we get 8, we sub in 2 here, we get 8 on 3, and then that's minus, okay? When you sub in the second one, minus, and put in a bracket, like avoid your silly mistakes, okay? Put in a bracket, sub in the 1 and then just do it normally, okay? 4 times 1 is 4, sub in the 1 here, that's minus 1 on 3, close your bracket, and we get 3 over 2 pi plus 8 minus 8 on 3, well that is 8 becomes 24 on 3, 24 minus 8, that's 16 on 3, so I'll still have the pi in there outside the bracket, and then it's 16 on 3 minus, okay, so 4 minus 1 on 3, if you want to do on the side you can, that's 12 on 3 minus 1 on 3, that's 11 on 3, so it's minus 11 on 3. Okay, so let's keep going with our calculations. The pi is still there. Let's add these two numbers up, and that should give us, actually we don't really need a bracket, might as well put it, 16 minus 11, that is 5 on 3, and then let's add them up. What do we get? Well, pi is pi, that's fine. Now it's 3 on 2 plus 5 on 3. What do we get with that? Well, common denominator for both of them would be 6. 2 times 3, 2 times 3 would get us 6, so 3 times 3 would give us 9. To get from 3 to 6, we multiply by 2, so we multiply the top by 2 as well. And of course, if you do that, that will give us 10. And your final answer is 19 over 6 and pi. Because this is a volume, make sure you put your units cube, and that's your final answer, okay? So 19 over 6 pi units cube, and that's how you find the volume of this acorn-shaped volume, okay? So that's pretty much it for this video, guys. It's a quick one, but it is a little bit tricky, so hopefully you found this video useful. But aside from that, guys, thanks for watching, and I'll see you in the next video.